Hello and welcome to the third Tech Talk session. Today, well, we have, as we had already the last two talks, with a mixture of infrastructure topics and use case topics. And yeah, I'm happy to show the presentations that will take place today. So on one hand, Kurt Garloff will give a short overview of the sovereign cloud stack. The title of the talk is Simplified Operations of Sovereign Cloud and Container Stacks with the SCS. And after that, Martin Voigt from Elevait will provide an overview of, well, the work they're currently doing in that domain. Maybe for all those who have not joined yet any of these sessions, well, actually, these tech talks are a sort of tool for us as Cloud&Heat to, well, get some interesting insights into different initiatives and projects that are going on. And on the other hand, well, we open it also for the public so that others can also join these talks, so that we, well, always have interested people also on board that may want to listen also to the talks. Yeah, I hear somebody typing actually. It would be great to switch off or to mute if you do not talk. Thanks for that. Yeah, and well, after the presentations are given, we can have a short talk about them, so a short discussion, and can also then try to identify maybe synergies, can try to identify some links to other existing projects. So feel free to, well, ask any questions that may come to your mind and that have relations to the topics that will be presented. Yeah, by the way, if, well, you would also like to contribute something in future, we already have two talks settled for or decided for July. Actually, I will show these two in a moment, but for some further tech talks then in September, October or something like that, if you have some input you would like to provide, would be great to receive further input. So any, well, presentation of initial technical concepts, for example, in the domain of sovereign open source infrastructures, for example, as well as maybe interesting use cases and overall things that happen on top of these infrastructures are highly welcome. Apart from this, definitely also implementation level discussions. So maybe some of you have also some ideas what to contribute in that context. So feel free to drop a mail. There is that mail address that yeah, will lead to some mail in the inbox of Maria, tech-talk@cloudandheat.com. And well, if there is anything interesting in that overall scope of digital infrastructure with a focus on open source, with a focus of digital sovereignty, well, point us to these topics, and well, let's then have a presentation in that group. This is a very short intro from my side, and with this, I'm happy to hand over to Kurt for presentations. Yes.
I am here, and I'm trying to share my screen with some luck. You should be seeing it even.
Yep.
All right, great. I'll run through this quickly. Maria told me I have like 15 minutes. Please, if something is not clear because I'm running too fast, you can slow me down, or maybe afterwards have questions.
Sorry for interrupting, Kurt. Okay, no, I couldn't see your presentation, but now I can see it. Sorry, just a second. Sorry.
Maybe it was just slow. All right, running right through it. Topic is simplifying operations of sovereign cloud and container stacks with sovereign cloud stacks. So we are obviously a project funded by the German Ministry for Economy and Climate Action, working on open source modular infrastructure that can be used to create, run, operate sovereign cloud and container infrastructure. I'll skip maybe my own introduction, maybe just a few words. I've been working on open source for all of my professional life in various companies. SUSE was the one where I spent the longest time. Maybe the most relevant thing I did was building up the Open Cloud as the chief architect, which is one of those public clouds in Europe that claims to be the largest. And And today I'm working for the OSB Alliance paid for by the ministry on the sovereign cloud. So that's my main job. And yeah, I've contributed to some open source projects like the Linux kernel and OpenStack itself and Kubernetes, Cluster API. I'm also involved with various associations. So quickly to start talking about digital sovereignty, because what we see recently is that this topic sovereignty has become a very, very important topic. Lots of companies and politicians and associations talking about it publicly. And maybe also notably, there's two offerings that claim to be sovereign. Recently, it has been launched, these systems together with Google, as well as Microsoft SAP Alvato. And what both of them are doing is that they're actually trying to fulfill the data protection requirements, GDPR regulations, by having clouds where technology that is used by one of these hyperscaler mainstream clouds, such as Google Cloud and Azure, but operating it locally in a local data center by a partner, by a trustee organization that has full control over the data, and this way, supposedly, no data can be leaked towards the software supplier that is from a foreign jurisdiction that would cause trouble and challenges with the Cloud Act and GDPR and Schrems 2 regulations. So that's what both of them are doing. The idea is actually not that new. Because there was, as some of you probably remember, Azure Germany, Azure Deutschland, operated by T-Systems between 2016 and 2018, which had a very, very similar model. And that was actually stopped by Microsoft in 2018 because it was not as successful as they had hoped it to be. So the idea is not new. What is new is that they're calling it sovereign. And I want to quickly, the next few slides, discuss sovereignty, because I have a strong belief that sovereignty goes far beyond just data protection, and actually that belief is shared by our government and most people that actually discuss these topics. We have a statement from the Digital Gipfel 2018, the Digital Summit in Germany 2018. I translated to English: digital sovereignty. The state-owned organization necessarily encompasses the complete control over stored and processed data, as well as the independent decision to make access it, and further it comprises the ability to autonomously develop, change, and control technologies of components, and to enhance them with additional components. So there's two components. One is the data control and data access control. The other component really being the ability to develop, change, the technology and enhance it according to the owner. So there's some ability to shape it, to further develop it. And we have a very similar statement from the Parliamentary State Secretary, Dr. Brandner, at the Open Infrastructure Summit 2 weeks ago in a keynote, where she basically also said, had those two angles. One angle really being about the ability to avoid dependencies that may introduce weaknesses, and the other angle to have this ability to innovate, to develop for yourself technology. What we have done is we have written a white paper where we try to a bit systematically assess the various things that people want and expect from sovereignty. And we've basically created like a 4 dimensions, 4-step ladder to sovereignty. And the first one, certainly very important one, is data security and data protection. So, I mean, those are laws that need to be followed, need to be obeyed. So there's not a lot of discussion. And the good news is organizations such as ENISA have come up with really good criteria and good list of things that need to be watched out for. And I mean, in the context of Gaia-X, we've also seen the Gaia-X labels, which have been modeled according to the different levels of data protection that ENISA has defined, which I think is a very smart move, because it's always good to build on top of good work that others have done. Second dimension from our perspective in that white paper is to have choice. So you have not a dependence on a single provider, on a single vendor with the things you're doing. And what that means is, well, what you need in order to have the choice in reality is, because you build applications on top of infrastructure, you use the automation, you use the APIs, you use the capabilities of a platform, which also means that your application actually becomes very dependent on these interfaces. So in order to have a choice, once you have deployed an application, you need to have a strong interoperability between the platforms. So you do not need to really reprogram all the automation of your application to have it runnable on a different platform. If you don't have that interoperability, choice is a rather theoretical thing, because the switching cost tends to be prohibitive. And then, of course, having a choice between just two providers may not be sufficient. So ideally, there's many vendors and many operators that provide compatible infrastructure. Third dimension, technology. So that was what Mr. Brandner said towards being able to innovate, being able to shape according to the own views and values that you have. What you need in order to have that is really to have transparency over the software that's being used, transparency also inside the software. So what we actually require from software that we consider a valid choice for sovereign cloud stack is that it needs to be fully open source. We do not believe that open core can be a valid model for what we are trying to do. And we also go a step further by requesting that the software is not just under an acceptable open source OSI compliant license, but also that there's an open development process, an open community around it. So the ability to shape it, to influence it, to contribute is real. So single vendor open source projects tend to not actually deliver you the ability to shape things as much as you need. The fourth one, very important, even if you have the software, the stack available, but it's so hard to operate it in a reliable, high quality manner, it still might not be fulfilling your needs. It still might not give you the freedom to run this software yourself, run the stack yourself, or actually find a partner that can deliver this as a service provider to you at an acceptable quality or an acceptable price. So actually having available operational knowledge, having transparency over the operational tools, the concepts, the best practices, becomes an important thing for such complex stacks, because running them really is not easy. This is just a warning. I mean, in this whole discussion, you will see companies that have very strong vested interests in trying to provide shortcuts into the sovereignty discussions. And I mean, you've probably followed the discussion around safe harbor, privacy shield. We currently have privacy shield 2 on the table. I'm curious whether there's going to be a Schrems 3 ruling from the European Court that will shoot it down. We don't know this. Maybe they have done it well enough this time. I have some doubts. And we also need to make sure we don't fall for very simple promises like, well, we have a local data center, and that, of course, makes us a GDPR compliant. It doesn't. We all know what Cloud Act means, unless you have an entity that runs the software, the infrastructure, which is under local jurisdiction. You have not won the law. Confidential computing is not the silver bullet either, because at the end, CPUs do process undecrypted data. Typically, there's some little special cases where you can get around that. And even if you can protect the data for the time period where it's in the CPU and then gets encrypted again when it's written back to memory, I mean, you still have some vulnerabilities there. And if you have solved them, then confidential computing still does not solve the availability issue. So you are running your important application and you're processing your important data on some platform that somebody can just switch off, you're still screwed. And likewise, I mean, be careful what you trust. Open, transparent are also terms that are very often used. The mission of Sovereign Cloud Stack is rather simple. If I put it in the context of this sovereignty definition, trying to achieve all the levels of digital sovereignty. So for data security, data protection, of course, it means building a secure platform that can be run by entities that fulfill all the data protection rules, and make sure that the design of the infrastructure of the platform is safe by choice, safe by design. Second choice really means that we need to find and work with many providers that are collaborating, that are building the platform together, that are defining the standards together, most importantly, and then also make sure we have checks in place to test standards compliance, where we can then also use a certification process to kind of document that towards the DevOps teams that are the users of the platform. Federation is a built-in feature that you need in order to make sure you don't need to do user management one by one on every platform separately. You want to do that in a virtual cloud way, just do the management once and use it everywhere. The ability to shape technology, of course, is closely linked to open source, as we said before. And what we believe is that together with standards, you also should have a fully a complete reference implementation. And the way we've built that is we use a very modular approach to that. So people can choose to just use the modules they need. And of course, we watch before open so that the software is open and that there is an ability for interested parties to contribute. The fourth topic is something we started working on, where we certainly have still some more work ahead of us. That's the large topic around open operations, really working with providers to provide transparency over the operational stack, over the operational practices, over the stages, over trouble that exists. So we also are very big supporters of public root cause analysis. And in the end, what we're really trying to do here is building a network of existing or upcoming providers, public cloud providers, could also be providers for internal needs that do that work together. Talking quickly about a project, young project. The idea was really developed in 2019 when Gaia-X started. And then we built it up from there. The project is now run by a small project team at the Open Source Business Alliance. We have lots of contributions from an open, diverse, lively, healthy community. But we also have the ability to pay contractors for some of the work, and we need to use public tender process to watch the money, because it's public money we're spending here. The way we see the role of the Open Source Business Alliance is really that we are the neutral party in the middle of this whole system. I'll skip over the Gaia-X view. I think people have also criticized that this old X picture is a bit outdated because the scope of Gaia-X has narrowed, but you can see basically that we are trying to support as the infrastructure ecosystem space, whereas the Gaia-X Federation Services that we work together with very closely try to build the links in the middle of this picture. I would summarize what we're trying to do with maybe just one headline, which is make it easy to provide a modern sovereign platform. And how do we achieve that? We create this open ecosystem and an open community that delivers a secure by design platform with certifiable standards for federated cloud and container platforms. We built a complete, fully open modular reference implementation along with the tools that you need to run it, and along with the practices, the documentation, how to do this in a transparent way. So we are trying to find partners that use some technology, maybe all of it, like such as Plus Server, for example, does, or maybe just some modules, and then work with us to further define the standards and to further develop the software, and then contribute to an open operations community where we exchange information on how to best run these platforms, how to build the automation, how to deal with challenges. This is the picture I'll skip. And by the way, I will share the slides with everyone, so I'll make them just perfectly available. We have already 2 releases behind us. The last one was March this year, where we really have much further developed the hardware automation, the automated installation. Our Kubernetes as a service platform built on the cluster API is the operation now is also being used by GXFS project, for example. And we have worked on the federation pieces to make sure we can link together as SCS platforms. And we have this half-yearly release cadence where we will bring a new release every 6 months. If you look at the reference implementation architecture, you will find a somewhat classical Loki stack. Loki is a term coined recently that describes the standard setup for open source cloud and container infrastructure, Linux, OpenStack, Kubernetes infrastructure. And we've really modeled our stack in the same way. Also, I think our reference architecture is a bit older than this term. Important, if you look at the architecture, is that there's operations tooling and identity access management tools across the stack that we support, not just the functional stack part of this definition. When I said we try to make the operational topics easier, I'll just show you one tool that we have actually built ourselves. Typically, we don't build a lot of software ourselves, but take open source software, configure it, well, first select it, configure it, automate the deployment, test it, validate it, and make sure the lifecycle management works. What we've done here is simply an own tool where we monitor, in this case, the infrastructure service part of the platform by constantly creating real world workloads on it and measure the API performance, the platform performance, and of course, measure also the success. The here is that in 1 week, we have created more than 10,000 VMs. And actually, none of them has failed, so this is a rather good week. Well, that's how it should be. I'll finish by saying we have been successful finding operators that are working with us, plus servers certainly, and with ISM, with the data cloud being the first 2 public clouds that are using sovereign cloud. But we're also working with the folks from Cloud&Heat, with Schwarz IT. We have some good, we have certainly good support from Stack HPC and Pleura, which have been supporting us from the beginning, and also some collaboration with Jonas Telecom Cloud, where we are at good scale, I want to mention as well, where we're defining some parts of the stack together and standardize, at least at some layers, all the work we're doing together. With that, I will close it so we have some time for questions.
Marius, you're muted.
Oh, right. Sorry for that. So, yeah, my question was if there are questions. Any questions?
I have one question. So maybe it's a little of a stretch to even compare this, but Google, for example, I mean, they created the Android universe, which is like open source and stuff. So companies who produce their own cell phones could just take this and create an experience for users where maybe the device that they're buying is different, but the platform on which the apps run, so they can have an app store and everything, is basically the same, which was a great idea. But then you have like all these version scattering. Everyone puts their relatively bad customizations on top of it and so on. And in the end, for the users, it's a little bit in a sad state. And I think that similar problems could arise if you try to have like a lot of cloud companies use the same software stack, and everyone tries to increase their own market share by adding small improvements here and there, which don't grow back into this community part and so on. Do you see potential like this in this whole thing too? Or
Yeah,
are
I
there
think that's
ways that you're already fighting them? Sorry.
Yeah, I think it's an excellent observation, by the way. I think that is one of the things you need to manage actively if you are building an ecosystem around open source software. We have a few levers to kind of avoid some of the fragmentation that you are describing. One is when we certify platforms, we are trying to establish SCS certification as a high value brand that actually our partners aspire to have. And we want to have strict compatibility tests in their and we automate this so that for the end user who's building applications and running applications on such a stack, they really know what they can rely on, and there's basically tests that prove that our platform complies. We actually go a step further. We also have a second certification step where we do not only require that all the system behavior and interfaces behave the way they should, so it's compatible, but we also require that the provider, the operator, is fully open with the software stack that's in there, including what are all the software, what are all the components, is it all under an open source license, are all the changes that have been made transparent. So we have some way to kind of discourage behavior that would fragment such an ecosystem.
Okay, but then let's say there's like one or two providers who take the whole stack, put their things on top of it, which are kind of deviating from the standard, and customers are starting to buy it like crazy. And then your authority in discouraging that is like mostly ignored. Is that something that, I mean, it can happen, right?
It certainly could happen. And I mean, there's no way we can disallow extensions. Actually, we don't want to, because disallowing extension also means that we slow down innovation rate to the speed of standardization, which we do not want to do. What we do want to do is make sure that if providers actually have extensions on top of the standard SCS feature set, that once users use them, it's a very deliberate choice. It's very visible to them. Then they are now relying and building on top of something that is non-standard. And users hopefully make then a deliberate choice to say, well, okay, at this point, I leave the portability advantage SCS offers to me. And now I actually deliberately choose the lock-in effect. And we need to rely on users to be smart enough. We just need to make sure it doesn't happen by accident. It needs to be very visible and deliberate. The other thing is, obviously, we're trying to build an ecosystem that is not just like two big players, but a lot larger. And if you have a lot more players, it's less easy for a single or a duopoly of companies to kind of say, well, I mean, we are much stronger than the standard, than the community. Let's just define we are the community. I mean, this only works if you have a small number of very large players, and we're trying to avoid that. I hope this answers the question.
Another aspect is like, I mean, Intel came up with this concept of the Ultrabook, or I'm not sure if that was the right brand name. I think it was Ultrabook. I mean, the problem was that Intel had like, look, we're providing chipsets that make it easy for you, laptop vendors to buy to create nice machines, but you don't. The market is completely scattered and whatever. So let's drive this. Let's create notebooks that are great and give you a certification that you can put on your own laptops too, in order to help you more to create some innovative things, because otherwise people are just buying MacBooks. And there you have one main driver who builds great laptops, and then you get innovation from that. Is that I mean, we're in a similar situation here too, right? So someone needs to drive this, someone needs to create the reference platform that's awesome, so that others find it easy enough to just follow this, and then we can have nice innovation.
It's fair, just to jump in here. I think it's a fair comparison. I think it is significant amount of work to try to build an ecosystem that has enough coherence, enough quality to compete with a single vendor that can just define it the way he wants. But I think this ultrabook is not a bad example. I think, I mean, x86 notebooks have significantly improved, not just the ones that have actually achieved that label, but overall compared to Apple. So I largely think, yes, it is comparable, and it's similar work we need to do to manage the ecosystem. I don't want to steal all the time from Martin. So Marius, it's of course up to you as moderating this, whether how much more time you want to have for the discussion on SCS.
Yeah. So we still have one talk to go. Yeah, is there any quick question still available? If not, I mean, you have the contact data from Kurt, and yeah, maybe there are some follow-up discussions also.
All right. Yes,
okay.
I'm very happy to. I mean, obviously, we really appreciate if people want to work with us, contribute technology or use technology, discuss, ask questions, find bugs, whatever. I mean, this is really what makes all of us stronger. So please feel invited.
Yeah, good. Thank you very much. So let's move forward. Martin, the floor is yours.
Yeah. Yeah, welcome and thank you for being here. Yeah, as elevait, we are basically really on the opposite sides and Kurt work is, so really on the U level of cloud stacks. And today I want to give a short impression how we want to apply the topic of AI for the public sector, and why we are thinking some kind of sustainability is required there on different dimensions. Maybe one short introduction to elevait. So we are a startup which has a vision to make use of AI in a sustainable way. And right now we are about 70 people, mostly situated in Dresden, as we have our development center here. Basically, we are headquartered in Triberg in the nice Black Forest. And as an technology vendor, so we are not dedicated to the public sector, for example, or nor to any other domain. We are driving different research and transfer projects to continuously evolve and our technology stack. Okay, the public sector has various challenges nowadays, and as you may know, the different kind of processes the public sector has are not digitalized. So there are, especially in Germany, and there are other countries like some Baltic states are quite much more improved in this regard. There nearly everything is digitalized, but I think there's at least here in Germany and other countries in the EU, we have big lack of digitalization. And this comes together with that especially the software companies delivering this IT for digitalization, etc., have also to update their technology stack with current state-of-the-art technologies, but also have the requirement to move step by step to the cloud. Yeah, for example, to have more efficient release cycles, deployment possibilities, etc. Having both together, the public sector has also the lack of employees. I think every company has it, especially in the IT, but the issue is also quite big in the public sector, where current statistics say that at least 330,000 jobs are open, at least in Germany. And this is not only just for the people who work in these processes, but also for the IT sector. And for many IT developers, it's not quite admirable to work in IT in the public. So they have different issues. And in the discussion with our partners and customers, we identified different main needs, also business needs. And this is especially regarding to the lack of employees, that we need to automate processes in different organizations. Since there are more and more people go to retirement, we have to preserve the business knowledge that people have. And also, since different processes change more often right now, and which are, for example, driven by Corona situation, new processes come up quite early and quite fast. So the adaptation of these processes need to be done quite easily, just mainly without coding. How do the processes could look like? So we define the processes roughly in three parts. So one are inbound processes into the organization, like input management, customer support, etc. Here's just one example from an energy provider who has filled forms to fill some applications and so on. Then we have internal processes in the public domain, which really completely through the organizations, like the accounting process. And there are also outbound processes, how to combine knowledge and data information to communicate the decision made in the public sector and transfer it to the people of interest. And maybe to make it a bit more exemplary, I took the input management process, since we have already 2 customers in this field, and also it's we are going more and more for digitalization. It usually starts with collecting different kind of inputs. So we have really the analogous way, like receiving faxes, receiving mails, which have to be scanned. We have emails, we have tickets, we have web forms, and so on and so on. Every kind of this information has to be added. Then, based on the different intents the company has to work on, or the departments have to work on, we have to classify them. We have to extract the information. So it's everything what the people are doing there. And then the people are validating, for example, against the CRM database they have, and so on. And sometimes they have also to enhance the incoming documents, etc., with other internal information to finally start some internal processes. So also it's quite exemplary, but this process is quite common. And now let's think about how to automate this. And what you can basically distinguish, and what you hear of automation today, you always think of, yeah, let's do it with AI. And here we should basically distinguish between, on one hand, statistical AI. And I think that's all what we mostly hear about when we speak about AI today. That's machine learning, or more narrowed down, maybe, for example, deep learning models, which crunching data, and yeah, we have some black box model to decide something, or to, for example, assist information extraction. But what was basically forgotten to some extent is that we need also symbolic AI. So it means we have to present business knowledge which is already within the company. And there are also different technologies available, for example, from the field of semantic web technologies, where you can present and define most important business knowledge, concepts, relations, logical rules, and so on and so forth. And we are sure that if you want to automate, you need both words, because every kind of knowledge you have in your business is represented in the data you have. Besides that, we should always think as software companies, how can we do also smart engineering? And here we really forced to work on a model-driven way, but also, for example, foster microservices as a design pattern to fulfill some functionalities. If we reflect this 3 rough ways in the process, how we would design it and how we designed it is that, for example, the input collection, we have an adapter concept defined, which is quite flexible and transforms, for example, every incoming document or, let's say, information to a standardized form so that it could be handled in an internal process in a homogeneous way. If we want to automate the classification task so that not somebody have to sit there and classify information, we make use of classification models, which are statistical models. But we should not forget, for example, to define these classes. This is really based on concepts of your business knowledge. And you have also to think of really to do a smart engineering here, so that you, for example, encapsulate these models based on microservice, stateless microservice, that you can easily exchange technologies, frameworks, methods for the classification, because the, let's say, the AI market is growing fast regarding methodologies and so on. We have the same for information extraction, like identifying entities and relations in the texts or documents. And if we come to the topic of information validation or information enhancement, here we are at the place where business knowledge, symbolic AI comes in. Finally, we start internal process, and again, maybe on a smart engineered way based on the information which is extracted, so that we have some adaptive process automation. So if we want to put everything on a software stack, we defined some main ingredients for it, and that is really that we apply statistical and symbolic AI in its core. So having not it attached somewhere, really we should combine it as smooth as possible. Then what is also important is that you rip out every kind of domain or customer specific data models out of the process, so that you can always develop against a standard, and at maximum you do some data mapping in and out in an outbound processes. All user interfaces you use have to create, which are relying on data structures, basically on domain or customer specific data structures, should be generated in a model-driven manner. And finally, from scratch on, you should think of to have the software platform defined for a multi-tenant and in secure ways that you can define, for example, permission, authorization, and authentication concepts really on data concept level, for example, and having this everything applied in a cloud native architecture. How it looks like in a rough way, we defined somewhat a backbone. We call it the data flow level. Here we rely on an open source framework called Apache NiFi, where we collect data, transform data, and move it where it should be. It has a lot of connectors, so that third party, like software vendors, can just give us an API, or let's say a file system, a database, where we load the data, transform it in our own data storage, and not in as a data lake as it was done, let's say, years ago, some years ago, just creating big data lakes. No, it should be related always to the concepts, the business concepts you have in your company. Further, what is absolutely important is that you have defined a machine learning level, so services fulfilling steps like classification or information extraction presented before, absolutely independent from the API of the third party, so that you always work on your data model, your intrinsic data model, so that the machine learning people can really concentrate on the algorithm development and not to crunch the data. And as mentioned, we have to have this user interfaces, for example, to make data viewable, editable, and so on. Everything runs on the cloud stack, and here, let's say the presentation of Kurt jumps in. Everything have to run on a potentially sovereign cloud stack. These parts are already developed in the first state in our elevait suite, and are proven right now with multiple customers of different domains. But this brings us why we also applied for the IPSE in this consortium. There are a lot of extensions required, especially for the public sector. And one of the really important topic is here data management. We had a lot of discussion with different organizations, and we had, for example, the issue that data, which is used for machine learning for statistical models, need to really be traceable from the beginning, from the source where we gathered it, until the model. So it's always possible to strip parts of the data out and so on. And how does it look like roughly? For example, we have in cloud, or maybe an on-premise installation of a solution like an ERP system, a financial system, CRM system, which we want to support with AI. As there need to be a possibility to export the data, or at least to gather the data. And from this part, we really need a versioning, defining status, but also to being GDPR compliant. What we want to do is that we create an anonymization or pseudonymization really at the side of the customer, so that no critical information leaves their cloud ecosystem. Having another cloud where we, as elevait, for example, or run our trainings, it means we gather the data from different providers, which is anonymized, we are versioning it, and then it's just used for training and benchmarking. And having models ready, we provide it back. So that means the customers can, let's say, leverage the different models we develop, maybe also about over multiple customers, like thinking of handwriting. If it's anonymized, for example, has no relation to a dedicated person, it could be used, let's say, for every solution. Another topic what we want to bring further is that our customers, or let's say our partner companies from the public sector, so the specialist IT, are in a state where they can define business concepts, rules, data schemas, etc., for their business processes without writing any line of code. And another topic is that they can also, since data sometimes have not to leave their cloud system, their cloud ecosystem, that they can manage data annotation on their own with some teaching, that they are in a state where they can define the benchmarks and start a model retraining and validation without really having detailed knowledge of statistical AI at all. Finally, what is really important is really this multi-provider deployment. So we have seen it already with this traceable data, where we can select a cloud provider based on meta information like security standards, like the carbon footprint, and so on. And there where we can also run a federated training of machine learning models, and also that we can automate our distribution or the deployment distribution of the elevait suite quite easily. And how it should look like. So we have a cloud provider, and here comes in this deployment stacks. That's basically the presentation by Kurt, where we have some standardization where we know how to deploy our software over multiple cloud providers. Right now we have the issue that the deployment looks different if we go to AWS, to Azure, or for example, to Cloud&Heat. And this is really a pain for a small company like us. On the other hand, we have our, let's say, continuous deployment stack. This is developed by us and will also be extended with this project. That means improving our data repository, where we basically rely on DBC. We have a model repository, we have a container repository where all our software is in, and finally a configuration repository, like for example, having the Helm charts. And this should make it possible to deploy it automatically based on this deployment stack, and this basically over multiple cloud providers. Finally, while we are working towards a sustainable AI in the public sector, it means having this kind of technology available, which allows us, for example, a fast implementation, a fast benchmarking of a solution. We can really strengthen the organizational efficiency of the different organization and make it measurable. And since we have tools to preserve knowledge from the business people we're working in, like defining concept and business rules, it's also possible that this knowledge is preserved. Also, automation supports employees who have not to work on this daunting task, like classifying things, writing, typing things, and so on, so that we have a social dimension of sustainability. And finally, also an ecological dimension, which is, for example, that we reuse our machine learning models over multiple customers, so that we don't have to retrain for every customer as good as possible, and that we really enforce that we running energy efficient, so having as small models as possible, but also using cloud providers with using reusable energy and having so a less or a low carbon footprint. So that's all.
Thank you, Martin. Yeah, questions about that? Discussion points.
I have one question. Like on your when you're building the machine learning models or the neural networks with all their weights and so on, that's of course the most time and resource consuming process of all, I guess. Yes. Do you have like specific requirements on? I mean, I guess you're doing that in the cloud. And do you have like specific requirements on like what kind of CPUs or GPUs or whatever infrastructure you have there? I mean, that's kind of an additional complexity on top the sensitivity of the actual data you're processing, right?
Yes, absolutely. And here in the past, we together with Cloud&Heat, we learned a lot how the infrastructure should look like, helping us. So having some preferences, for example, regarding the GPUs, having also preferences regarding the data transfer between CPU, GPU, etc., and storage and so on. This is where we did different kind of benchmarks, so that our machine learning people are quite positive right now, having stable infrastructure there. And this meta information we gathered over the time, we can also leverage, for example, in the project, in the next steps. But I'm too far away to tell you which kind of CPU version, etc. from we couldn't recommend. But we have also other issues. Maybe you should do one small addition. We have basically really to distinguish between the training time and the prediction time, whereas the models are usually much smaller and should be also quite fast. But here we have definitely the issues that say deployment have to be also cost efficient as possible. So this is another dimension.
Okay, and I mean, your machine learning models that are kind of the result of weeks-long number crunching on some kind of some kind of cloud provider. When you switch the cloud providers for every generation of the machine learning model, do you get differences in the models just because they have different hardware or anything else? Is that also a problem?
So this case we had not. So what we can also say that that we use different kind of GPUs on different setups, and here I think there were some small differences, but I think the issue was not that dramatical. So we have different, let's say we have two kind of GPUs or setups running. One is really to have some fast experience if the model could be improved with some, for example, data changes in the data, or with defining other hyperparameters. And if the team usually thinks, okay, that's something to test, then we go on, let's say, bigger GPUs.
So we only have a few moments left. Are there any quick further questions?
I think there are some questions in the chat.
Yeah, was just a comment to the discussion. I would assume if your machine learning models work like I've seen them before, if you have a huge amount of compute power requirements for the training phase, but that the inference typically is not so much of a problem. I'm just wondering whether that's true.
Yes, that's definitely the case.
Okay, further questions?
I do have a question to Martin. We're also using machine learning tools and typically using predefined toolboxes like TensorFlow, for example, or Torch. Is there something out there already that allows you to combine the symbolic artificial intelligence approaches with the machine learning tools?
Right now, so there are different kinds. So there are some models. So it basically does not rely on, let's say, a framework like PyTorch or TensorFlow. There are some for different kind of problems you want to solve. You can also make use of data structures from the symbolic AI. So I think just from a model point of view, things are converging. So for example, in the knowledge graph work, more and more technologies come up, for example, for link prediction and so on, for disambiguation and so on, which make more and more use of neural networks. But there's also discussion between having black box models and white box logical reasoning. And you have always to decide in which state of the model development you want to use and apply which kind of technologies, because you really lose the traceability.
Because it's basically tailor-made solutions that you're working on.
Yeah, I would say tailored, specific to use cases.
Okay. Thank you.
Okay. So Martin, maybe you can unshare your screen that I can.
Yes.
Very briefly, the hint for, well, next talk. So as mentioned, we have already 2 talks planned for the 28th of July. One about Kubernetes as a service with Garloff. I think that's definitely also a good addition to the SCS presentation that Kurt has given today. And apart from this, from Cloud&Heat, an overview of cloud services for Earth observation data exploitation. So yeah, we will have these 2 talks on the 28th of July. I hope that, well, maybe we created here interesting links also among you. Maybe the things that are interesting for you, and there will be follow-up discussions between you afterwards. So unless there is any, well, quick comment or quick discussion point, I would like to finalize and close this session, and, well, hopefully see you in the end of July. Have a good time.